Good afternoon, everyone. This is Megan Jones from ICEA, welcoming you to another one of ICEA's Webinar Wednesdays, featuring one of the presentations that were scheduled for our workshop in San Antonio. This and all distance learning webinars this summer will count as 1 hour towards your CCEA recertification. So those of you CCEAs out there, keep your confirmation in your records for when renewal is due. So when you guys signed up for today's webinar, I doubt you realized you were about to be addressed by two ICEA celebrities. Our authors today both won 2020 ICEA Association Awards. Ben Berkman was part of the CADE training team that took our Educator of the Year award, and Ben's co-author Justin Cooper was named the 2020 Junior Analyst of the Year. Ben and Justin have a lot to say about R today, so I won't delay them any longer. Guys?
Yeah, thanks, Megan. And yeah, good afternoon, everyone. Thank you for tuning into our ICEA webinar today. We're certainly disappointed we're unable to present to you in person, but we're excited to present our work to you nonetheless. So today we'll be discussing really a summary of work that has come out of our 2020 ICEA conference paper, and that paper was titled The FlexFile Framework, Preparing for Powerful Analysis in R, and that's available on the ICEA website. In this presentation, we're really going to focus on 3 R packages that we've created to work with the FlexFile, and these R packages are part of a larger initiative at Technomics where we both work called the Costverse, which is really a collection of packages to facilitate cost analysis in R. So again, the packages we'll be discussing today specifically regard reading in, analyzing, and then visualizing the FlexFile in R. And as Megan suggested, we recognize that you may not know what either a FlexFile is or what an R package is. So we'll describe both of those as well. So you can't see us, but who are we? My name's Ben Berkman. I'm a lead analyst at Technomics. I've supported the OSD CADE project through the Defense Cost and Resource Center, the DSARC, for 3 years. In that role, I've worked very closely with the FlexFile initiative, working with industry on providing data and working with the government in reviewing the data and developing solutions in R to streamline that whole process as well. I've also done a fair amount of training on the FlexFile, informing both industry and government of the data requirement. Earlier this year, I also gained my ICEA certification. So today, I'm fortunate enough to be joined by my colleague, Justin Cooper. So Justin, over to you to introduce yourself.
Thanks, Ben. Yeah, and I've been at Technomics for the past 2 years, working with Ben as a senior associate on the OSD CADE project through the DSARC as well, where I've recently been working on the new 1921-3 DID update, as well as leveraging R in reporting for compliance metrics. So I think with that introduction, we'll jump into the agenda to see exactly what we're going to be talking about today. So we're first going to go over some basics, which can really be divided into 4 points. The first one is, what is the FlexFile? Briefly, the FlexFile is the newest version of CCDR reports. They supersede the 1921 reports after the new DID was published. Secondly, why use R? We understand we probably have a mixed level of familiarity in the audience, from power users to those only knowing it as some kind of scripting software people use for data analysis. Well, don't worry, we're going to briefly explain it and its advantages and general use cases for all levels in the audience. So naturally, what comes after that is really discussing why use R with the FlexFile, bridging these 2 first concepts together. And finally, why use R packages in particular. We'll explain why a package is the most professional and efficient way to share a code, but for a brief introduction, a package is the fundamental unit of shareable code. It's really just a collection of functions, documentations, and examples. So after all that, we'll get into the Costverse, which is a collection of packages developed around a similar design philosophy to really facilitate leveraging powerful R tools throughout the cost community. And today we're going to focus on discussing the FlexFile Costverse packages. This is limited to reading, analyzing, and some light dashboard work of the FlexFile. That was the focus of our ICEA paper in 2020. Then we're going to jump into a nice demo within the R environment of these packages relating to our ICEA paper, and then finally wrapping up with a little bit of how to learn some more and a short Q&A to follow. So I think with that, Ben, are we ready to dive right in?
Yeah, let's do it, Justin. So before we can really, dive into R and really show you some code, let's understand a bit better the data format that we're discussing today. So the FlexFile, again, it's the newest series of contractor cost data reports, also known as the CCDRs. As of May 2019, the FlexFile replaced the 1921 series of reports as the required version of CCDRs on all new contracts with a CSDR reporting requirement. So the 1921 reports, and we'll also be calling them the legacy reports, provided us costs and hours really broken out just three ways: by a government-defined WBS structure, by these government-defined non-recurring and recurring definitions, and by these government-defined standard functional categories: direct and overhead, engineering, manufacturing, and material costs. And additionally, these 1921s, they were created in the 1970s, so their format had become a little bit outdated. As you can see on the right, we initially received these 1921 reports as handwritten forms that were faxed to our office. Now they're submitted in Excel, but the general format hasn't changed much. The FlexFile, meanwhile, it follows a much more modern data model. Its native format is something called JavaScript Object Notation, or JSON, and this is just a much more efficient method of storing a lot of data than an Excel workbook may offer. Additionally, the FlexFile provides all of the data that was in the 1921 reports, but also a bunch of additional insight. This includes time phase costs and hours reported at a level lower than the WBS, something called the account level, and costs and hours tagged to contractors' native pricing categories, something that aligns with what they might propose on an FPRA. These are not government-defined pricing categories. So the image on the right really just shows all of those FlexFile data groups. It's a much more organized collection of tables than the 1921 reports. And if you'd really like to learn more about the nitty-gritty of the FlexFile, I'll shamelessly plug the paper that Mark Stevenson and I wrote last year for last year's ICEA conference that really introduced the new data format. But overall, the big takeaway is that this new data format, the FlexFile, is submitted in a much more efficient data model and contains more detailed data than the 1921 reports. So for those reasons, we really believe it's this perfect data format for a tool such as R. But really, what is R and why do we use it specifically? I'll turn it back over to you, Justin, to explain that.
Yeah, Ben. So I think the first thing to go over really before briefly talking about R is really discussing Excel, which has really been an important tool for the community for a few key reasons. It is available on every government and industry workstation. It's pretty easy to use, and with some experience, it is possible to become a power user. So due to these reasons, it is often the tool of choice for analysts, and it can be the correct choice. But once some more thought is put into what type of tool you need for a specific solution, the issues with Excel become glaring, and that's something we found when working with the FlexFile. So first, there's definitely a lack of consistency. The amount of flexibility Excel delivers is both a blessing and curse, as in the same column I can have a numeric value and then something completely unrelated 20 rows down, possibly the definition of a word. So with an experienced user, this flexibility could result in a pretty robust workbook. But the example I just gave, it can really become a highly unorganized workbook that isn't really conducive to sharing. There's a lack of object language. Reuse of analysis through VBA is pretty difficult, and it's definitely not the easiest language to work with. There's a lack of statistical features as well. Modeling is pretty limited. Anything more robust than a simple linear regression for a cost estimate can only really be accomplished through either a power user or Excel add-ins. There's a lack of scalability. As we all know, Excel does have a clear limit. It can only hold a certain amount of data. So when discussing larger data sets, such as the FlexFile, this can really become an issue. The lack of graphical features. Visuals are pretty static. There's not a very reproducible nature of them, and it's difficult to use on other data sets. And finally, it operates on a fixed state, simply meaning Excel cannot handle vector inputs. One cell can only hold one value. So again, this becomes an issue with the problem of reading in data sets with multiple tables and a structure that comes in, such as the FlexFile, as Ben explained, coming in a JSON format. So for projects and development of custom tools that will be used at scale, a more consistent approach is definitely needed, which is why we're talking R in the first place. Along with this, Ben and I learned R on the jobs at Technomics, working with our data science SMEs to understand how we can more efficiently tackle our day-to-day problems, not through programming, but really analysis. R checks all the boxes listed above, and importantly, it is also open sourced, I want to say that, and widely available throughout government machines. So being open sourced means that the community has been able to publish packages, similar to what we're describing today, that really have developed over time into a very popular framework to leverage from. Some of the power users in our audience might know that Tidyverse is one of these. It's a set of packages, for those unfamiliar, very popular for data manipulation and visualizations. It's so popular, it's even become synonymous with R and has really helped the data science community create a framework for working within R itself. So finally, I'll leave you with the quote on the side, which wraps it up pretty well. R Studio's chief scientist, Hadley Wickham, calls it a collection of R packages that share a high-level design philosophy and low-level grammar and data structures. So I highlight the Tidyverse not to be the end-all be-all, but really the framework we leverage to build out our custom tools for the reasons described above. This was all to say a more powerful scripting language was needed for the tool development of a data set such as the FlexFile, and we'll introduce some of the other Costverse packages that also leverage the Tidyverse workflow, using it as a general framework for efficiently working with these problems. So now that we have a brief introduction, Ben's going to describe why use R specifically with the FlexFile and some of the benefits we've seen there.
Yep, thanks, Justin. So now we understand a bit more about what the FlexFile is, and we understand also what R is. But really, why should be using R when working with the FlexFile? And more so, why is it even necessary to be using an R package when working on something with this scale? So we're really just trying to do what the Tidyverse did for working efficiently with data before the FlexFile. So when working with data or when working with a custom format such as a FlexFile, there are constantly these necessary and repetitive tasks that exist in order to manipulate the data into a format you want to use it in. This could include reading in the data in a consistent way, filtering data to just get a subset of the initial import, or creating new variables from existing ones. So again, R is really this open source platform filled with these custom tools, these custom workflows. The Tidyverse is a great example. Our packages, we've essentially built this custom tool for the cost community, but specifically for the FlexFile. We believe it's the necessary steps needed to standardize working with the FlexFile in R every time you use it. And at Technomics and on the CADE project, we work with R extensively, and we work with CCDR data and the FlexFile extensively. So anyone using it proficiently finds that you repeat many things. Again, how you read in the data, how you manipulate it into the necessary format. The idea of a package is a way to share these custom workflows. For something like reading the FlexFile into R, it's not only helpful, but it's really only obvious to bundle this into a package. It would be extremely inefficient to hand around, just a snippet of code to everyone without proper documentation or clarity. A package provides the documentation, the examples, and the necessary functions to do these necessary tasks. So to kind of illustrate that example, here's one good example of why you should maybe organize your code in a package. A very common task with the FlexFile will be reading into data and creating one data frame containing data from multiple FlexFiles. So just pause for a second and think about the necessary steps to convert the .zip folders of JSON files into a standardized data frame in R. It's a lot of effort, and we try to brainstorm it here. So you have to take the necessary steps to manually read in 15 plus JSON files into R, join 10 plus lookup tables, apply allocations if there are any, add a unique ID for each FlexFile, then repeat this for each FlexFile, manually stack the files into one data frame, and kind of hope and pray this works every time you do it, for the next FlexFile. So there really is a need for a custom solution to do just this very simple task. And that's essentially what we've created. With just 5 lines of code here, you can point R to a folder path, and it will create a reliable data frame to begin your analysis. We'll certainly explain these functions in more depth later in the demo, but just, this highlights the efficiencies gained when working with custom packages in R. So Justin, do you want to provide maybe one other good example of why we might use packages for working with the FlexFile?
Yeah, so this example should really show more of the workflow behind engineering a package. which is really not only recommended, but just about required when working at scale with these custom R scripts. And I would define scale here pretty loosely. It could be 2 or more people, possibly even just yourself, that these are often used in iterative tools. So anyone using R, even proficient users as myself and Ben, will find themselves repeating many things. Shareable code is the idea here, as Ben alluded to. Instead of sending around snippets to your coworkers, a well-curated package is the most logical way to implement this. Copying and pasting, sending back and forth these files really causes some bottlenecks that I've seen and probably many others have as well. The code can break and not really work properly, and you definitely run into some versioning issues. So the goal here is really like any other. It is tricky though. Cut out inefficiencies while increasing the quality of work. So now on the right, you'll see a little graphic to kind of bring this home. The solution's pretty clear. Development from authoritative source will build, test, and create for you. They will then disseminate to their user base, which will reuse the package, report bugs, and send those back to the developers, which will then cycle around, and they will continue to use their qualities and release the next version of the package. All these versions will be stored. So just like how you have files that are saved and renamed that cause issues, you can always revert back to a version. And this cycle really helps cut down on issues that were described above. Users will never be using half-made functions and will always have a fully operating package to use, while developers are testing, getting out bugs for the next version. Once it's stable, will they release it to the user base and allow for the best values of iterative design to really be implemented here. So now let's see where the FlexFile packages really fit into the Costverse that was alluded to before. Ben, you want to do that?
Yeah, absolutely. So I recognize we've really been speaking a bit in the abstract. So now let's get into the actual packages that we've developed. As mentioned, the 3 packages today are part of a larger technomics initiative called the Costverse. The Costverse is really an open ecosystem of packages for the everyday cost analyst. These packages are intended to work with one another and facilitate all sorts of cost analytical tasks in R. We hope these packages really become the standard for conducting cost analysis in R. So again, we'll only focus on the FlexFile specific packages today, but we do want to show an overview of all that is or will be included in this Costverse universe. So first we have what we're calling the core Costverse. These are packages for working with WBS structures, escalation and inflation, developing cost estimating relationships, and some miscellaneous functions as well. These are really packages for completing functions or working with data structures that all cost analysts work in. Next, we have these data helper packages. These packages really support specific data formats. So this is where the FlexFile comes in, and we also have the team working something very similar with EVM data. And finally, we have some packages to facilitate working with other tools. So FF2DB, for example, is an R package to facilitate moving a flat file into a database. So again, with the Costverse, we have these core packages that support common cost analytical tasks, some data helper packages that work with specific data formats, and then the additional Costverse packages to maybe work with some other tools as well. So that's the Costverse in a whole. Let's now dive really into the specific FlexFile packages within it. Again, the Costverse for the FlexFile is made up of 3 packages. Read FlexFile, which handles reading the data into R and creating a tidy flat file. Easy FlexFile creates these summary tables and exploratory plots of the data. And then Shiny FlexFile produces an interactive dashboard for a user-selected FlexFile. These 3 packages, they're really intended to build on each other. That means the flat file that we create from the read FlexFile functions is required for the functions in the easy FlexFile, for example. And we've done our best, as Justin alluded to really mirror the tidyverse and tidy data philosophy and syntax as well. So for example, much as the tidyverse has a read Excel function, we have a read FF function. FF means FlexFile. And we also have functions that support not only the FlexFile, but also the quantity data report. This report is often submitted with the FlexFile and provides necessary quantity information to tie to the cost and hours reported on the FlexFile. So we're going to briefly review each of these packages, and then we're going to really show how they work in a demo. So again, read FlexFile, it is functions that support reading the FlexFile into R. And we start with read FlexFile because you're reading your data into the R environment is really the necessary first step when working with any data format such as R. You need to get the data into R before you can do any analysis with it. So readFF from the read FlexFile package reads the FlexFile into a list of tibbles. A tibble is just a specialized R data frame. StackFF stacks these list objects of multiple FlexFiles, allowing a user to work with more than one FlexFile once. And finally, these flatten functions produce a data frame from these list objects. This data frame is essentially the FlexFile that can be used for analysis. We have another function, allocateFF. So certain FlexFiles will have allocations that need to be applied. So this function really just checks and then applies allocations if necessary. Again, the beauty of the Costverse is that the packages interact really nicely with each other. So read FlexFile relies on some packages from some functions from the cost miscellaneous package. So for example, the read folder function allows a user to point read FlexFile to a folder of FlexFiles and read in a group of FlexFiles at once, while add ID column and list index to column allow the user to assign a unique ID to each FlexFile they're working with. So that's all of the work that goes into reading the data into a consistent flat file. Now we have some fun functions and packages that really explore the data itself. So Justin, back over to you to explain those.
Thanks, yeah. So the next logical step really of package curation was to analyze the FlexFile after it's read in. So after we leverage read FlexFile, we're left with a well-structured standard flat file as been described. With this, analysis can really be taken in a number of directions. Easy FlexFile offers an easy way to visualize any FlexFile with a wide range of customizable visualizations. So the first thing Easy FlexFile allows for is the recreation of legacy reporting information, such as the 1921 suite of reports. Legacy and current analysis will find it vital to convert the FlexFile into the 1921 suite of cost reports. So with that in mind, it really was a must-have and one of the first functions we developed in Easy FlexFile and one of the first ideas we had when sketching this out. Other helpful functions that will go along with this are the WBS dictionary, which will give you a table of the dictionary as well as the WBS elements involved, as well as some other new fields that are only available through the FlexFile, such as accounts, as well as industry functional categories. These will be fully illustrated in the demo, but understand that these are also some new tables that are coming only due to the FlexFile's expanded data fields. Also, along with this, we support some generalized plotting functions that can really be customized with specific arguments within them. So one plot function can adapt to the user's interest and really point you in the direction you want to be looking into. First, the PlotBar function allows for legacy concepts to be visualized, meaning it doesn't require the time phasing of the FlexFile. It will show WBS element by cost and really fill the bars by any category you want that are pre-decided by us. So standard functional category, for example, you might want to look into, or the cost type, non-recurring versus recurring. So these simple charts can really be altered to design and really feature into what you want to look into. Finally, we included some other powerful visuals that help identify the new areas within the FlexFile that can be leveraged for analysis. These are illustrated through Sankey and Sunburst diagrams. Don't worry if you haven't heard those before, we'll go over them shortly, but they're really great visuals for understanding how the hierarchical categorical variables in the data set of the FlexFile interact with each other. So after that, finally, the last package we've been working on within the FlexFile portion of the Costverse is the Shiny FlexFile, as you see in the last section of the bars up top. This really only contains one function. There's not a lot on this slide, but it's pretty powerful. It launches a Shiny dashboard. And for those of you who do not know, Shiny is R's package for dashboard development. Right now, it's still in the developmental phase. So going back to our package engineering slide, we're still really in the first release of this concept. and a stable initial release isn't ready yet, but we're working right now to wrap that up and tie really all this work with a nice bow on it for you. So I think with that in mind, after describing each functions within each package, I think we're ready to jump right into a demo and see how these things interact with a real Flex file. Ben, you ready for that?
I am. So yeah, thanks, Justin. We want to take just a few minutes to show some functionality of how an analyst might benefit from using our suite of FlexFile packages. So as I mentioned, the FlexFile in its native format is really just a zip folder of JSON files. And these JSON files, when you open them up, they're really just text data. You can't do much with them without some sort of tool to parse the JSON data into a more familiar format. So this is an example of the end item table in the sample Flex file. Again, good luck really doing much with this data without some sort of custom tool. So yeah, Cade is certainly one of those tools. It has exports that format the JSON files into Excel files. Each of those export options provided by Cade, however, really only provide either some subset of the data or the full data in a more rigid format, such as an Excel workbook, which can be challenging when working with relational data, such as the Flex file. So our packages, they're really just another custom tool, but we believe it's the proper tool for working with the Flex file, especially in R. With our packages, each JSON file is turned into a data frame in the R environment, and these tables are stored in something called a list, which makes accessing any table quite easy, and iterating through those tables quite easy as well. This allows you to work with the full extent of the data in a format, a list that is quite, again, easy to work with. So jumping into R, I'm going to show you how we read in the Flex file in its native JSON format. So here I am running this first line of code right here at line 8. I am sourcing just some fake data stored in our read FlexFile package. So this data is actually stored in the package. Any user could access it. And then I'm going to read this read FF function to read the data into a list object in R. And a few things are happening here. You might have seen all of this pop up on the bottom of your screen. All of this information printed to our console is the FlexFile format check. This provides some really helpful information about the data that's being read into R. It will tell me which files and which fields were omitted from this Flex file. So for example, again, fake file we're looking at, the metadata table did not include some information about the reporting organization, the cage code, or the country they're located in. These aren't required fields as defined in the FlexFile data model. So this is more just a really helpful warning than actually an error. And you can also see here that the data is now stored in a list object called FF list. And let me open that up right here. So we can see that each table in the list contains the data representing the different tables in the Flex file. So as I mentioned, some Flex files contain allocations. So I want to run this allocate FF function to check if any allocations are needed to be applied. The function in this case returns the warning, no allocation table returning input, which is just telling me, the user, that there are no allocations that need to be applied. So it's just returning what we inputted in. However, if allocations needed to be applied, this function would automatically apply those. So next we have the function flatten FF, and this creates a data frame of the cost and hour data. And I'll open that up right here. This data frame includes both actual and forecasted values, applies any allocations, and includes several additional fields from other tables in the Flex file. This is really the data frame that an analyst would spend most of their time on when analyzing the Flex file in R. And this data frame really does follow that tidy data format that we mentioned. Our package also supports reading in multiple Flex files. So again, with the read folder function, we can point the read Flex file function to a folder of Flex files and read in more than one Flex file and create really this nice stacked data frame of multiple Flex files. So here we're reading in 2 Flex files stored in the package, and I'm not going to run this just because with screen share this can lag just a bit, but do recognize this is a very important capability. So yeah, just pause. That might have been a fair amount of information, and we don't expect you to memorize exactly how to do all of this. So there are really 2 ways to get help when working with these with these packages. So the first is our package website. It's an HTML file that has some documentation on each function within the package. So you can just click on any function and get this nice example page that provides detail about the specific function, detail about the arguments it takes, and some examples as well. We also have some more longer form examples. These are called vignettes, and they really show how to complete, for example, a full task. So here is an article, a vignette on how to import one or multiple Flex files into R. So kind of that whole workflow we just described, you can really just work off this template. Also, we'll shamelessly plug that our ICEA paper is also stored here. So if you want the full background information, you can view it right there. So yeah, so now we have that, that consistent data frame, and we can now use other functions that really only require this data frame to do some quick analysis. And these functions come from the easy FlexFile package that Justin introduced. So table 1921 prints the equivalent of the 1921 report extracted from the FlexFile data. Table 1921-1 does much the same, but for the 1921-1 report. And as Justin again alluded to, being able to create these legacy reports was really one of, if not the first requirement when creating the Flex file. So with only 2 lines of code, we can easily recreate those legacy reports. We have a few other tables as well. Table direct rate prints the direct labor rates for the given functional categories. Table top N accounts displays the accounts that most drive the cost. You can specify how many accounts you want to show with that N argument. And finally, table WBS by date. It's almost a time phase 1921 showing costs by WBS element by time. So kind of combining the legacy reports with some of the power of the Flex file. So those are just, some kind of boring tables, but we also have some nice visualizations. So Justin, do you want to describe those capabilities?
Yeah. So the first and most basic visualization of Easy FlexFile is the PlotBar function. So you'll notice the function here has 3 arguments within it. It takes in a flat file, so a flex file, a type argument, and a unit. So for now, Ben has just ran that, and let's see what this results. As before described, we have WBS element on the x-axis, as well as the percent by cost on the y. The cost type can be shown, and actually what Ben's showing right now is a really useful feature. This being built through the package Plotly in R, we're able to see exactly what data fields are represented in those bars itself. So this being a fake flex file for today's demonstration, the costs are pretty uniform between non-recurring and recurring, but to me it's pretty clear that 1.4 looks like the largest non-recurring value. This is easily discernible. We can hover over and see exactly what data fields are being described. But if we're a little confused as to how to customize this function, Ben described there were 2 ways to get help before. This is the other way. So just like any other package, we talked about this almost ad nauseum before, but it's very important. Documentation is key. So by running the question mark in front of the function as Ben just did, you can see on the right-hand side, documentation we wrote for this function is available. So it comes in a pretty concise way, and you can see exactly what the arguments are that this function takes, as I alluded to before, as well as what kind of inputs that you can use for those arguments. So the type argument, it looks like there's a usage for PlotBar types. We'll provide a table of our available types, so we might not know what type 1 is. So if we use that, following the documentation guide, it will output in our console that nice little table right there that shows exactly which number corresponds to what type of flex file visual we want to look at. So we might want to look at type 2 by standard functional category, and maybe instead of this time, we want to change the unit from percent to dollars, so we can see what that will give us. And on the right-hand side, as that renders, again, the same function, PlotBar, with a few different tweaks from the arguments, and we are left with a completely different visual. Now we're looking at WBS element by discrete cost values, and we can clearly see the majority of the cost is coming from that light teal color, which I believe is the direct engineering labor. So depending on what submission you're looking at, you might be looking at something that is an outlier, or something you might want to delve into a little further. So if that is your option, and that's what you find yourself wanting to go to. This being built all through the tidyverse lens of data manipulation, it's pretty easy, even if you don't know R, to be able to filter this flat file on line 56. Just so we're not lost, you can see the filter action. WBS level will go to the filter of level 2. And then if we run the same function with that flat file we've now filtered, the beauty of all this workflow is we are now left with a visual of that filtered data set. So now we're looking into only level 2, 1.2, 1.4, and 5 are now available. Again, the same visuals from that function are going to be visualized. And the repeatable documentation of this should really start to becoming pretty clear now. So again, we touched on the plot area function in the PowerPoint. Now let's see that one in action. Again, we wanted to build this in a very similar way that was very reproducible and easy for the user. So the arguments taken are the same. You'll notice you have a flat file, a type, and unit. For this one, we are finally unlocking the new data fields of the flex file that it is time phased over time. So these submissions now you can look at how these costs are tracking over time. And this in conjunction with the PlotBar can really open your eyes into what you're looking at from a high view and where you might want to go in the future with your analysis. So moving along from the PlotBar and plot area, we discussed a few of the newer functions that unlock the hierarchical nature of the flex file. You know, the new data fields that are given to us are very valuable. So the plot Sankey function, if you've never seen one before, on the right-hand side, you can now see a Sankey diagram. This is now looking at the industry's functional category on the left, how they report, and how that rolls up into the old 1921 -1 functional categories from the government to defined side on the right. So we can clearly see that industry reports on a little bit finer level, which is actually really insightful and great to see. And we can actually understand where those costs are allocated towards the standard functional category as we're used to seeing with them. Again, a lot of this analysis is going to be critical to be able to bring back to the 1921 legacy reports, as there are a lot of data available on those and analysis already taking place that will need to be continued. So the fact that we're seeing a lot of direct engineering on the left-hand side, again, we might want to filter that down to just direct costs. So simply if we do that using the filter action, the director overhead field is one added by read flex file, and then plot that using the same Sankey function as before, we will get a little bit more, magnified view of the direct costs. Again, on the left-hand side, we see the lower levels, and now it's pretty obvious to see that there are 5 labor categories going in, and then that other untouched labor on the bottom can really be shown that are split off between the contractor's native categories. So again, that might point you in a new direction you want to pursue. Let's see what type 1 gets us for the plot Sankey. Similar to the PlotBar, that's what's going to change the fields that are viewed. And this one is definitely a different but pretty powerful in its own right visual. So on the left-hand side, we'll see the WBS parent element and how that flows to the account, which is the level at which the contractor reports their cost. This is definitely pretty eye-opening in the sheer amount of accounts that this flex file has. So again, this is where it might be pretty important to filter down. Our cost driver here looks like 114. We might want to see what's really involved just in that one. So again, I won't explain it again, a quick filter and then if we rerun that same old function, plot Sankey, we will be left with just that one element now in that new data frame, which is now corresponding to all of the accounts that make up that 114. And again, just some slight nuances to this visual. You can start to move around as Ben has been doing. If you know that there are a couple accounts you want to look into, bring them to the top so you don't lose them. From the beginning though, it is ordered by discrete amount. So all the way at the top on the right-hand side will be the largest account that is attributed to the cost of 114, and the one on the bottom will be the least. So with that, there's a couple of tooltip options, right, as Ben's hovering over. I think we'll wrap up the demo there and move into how to learn a little bit more about these functions and moving forward, as well as a Q&A section, which we've allotted some time for.
Yeah, thanks for that, Justin. So we'd love to show you, some more functionality even how you can use these tools for the data you're working on your program. Unfortunately, we're pushing up on just about being out of time. However, if you're interested in learning more about these packages or the Costverse in general, please do reach out to us. Feel free to reach out to either Justin or myself or Adam James. The three of us developed the R packages for the FlexFile that we showed today, and Adam is leading the Costverse effort more generally as well. Many of you probably know Adam. He's been involved in ICEA for a number of years. Our emails are here, so again, please do not hesitate to reach out. And finally, one last item. We have been asked by Megan to just plug the abstracts for next year's conference. ICEA 2021 is still scheduled for May 18th in Minneapolis, and abstracts are being accepted until November 3rd, and they can be submitted at the link on this slide. So yeah, once again, done. Thank you. I
was expecting to do that, but thanks for taking that one. Good job.
Do you have anything to add?
I couldn't have said it better.
Okay, great. Yeah, so again, we really do appreciate the opportunity to present to you all today, albeit virtually. And we do have, a good amount of time still for questions. So I'll turn it back over to Megan and the audience. Thank you.
Yes, just we do have a few questions. I'm just going to need 1 second. Jeff, whose last name I'm not going to brutalize, so you know who you are. Are you ready with your question? Okay, we'll come back to Jeff. Chandra. Let's get you up here. Go ahead, Chandra.
This is for the team. My question would be, I know R is a very powerful software, at least analyzing software. I've used it before in academic side, and we are trying to incorporate in our day-to-day analysis work. But looking at the government, which is like about 2 to 3 versions, 2 to 3, maybe more versions behind, how will it work? As well as if this is allowed on the government system, because a lot of libraries within R are not allowed on the government system. So will this hamper if we try to use it for this? Will it hamper, or you guys will be the ones who will be running all the analysis?
Yeah, no, that's a great question. We definitely want to ultimately, the analyst be the one using the data, being the one using the packages. So these packages, while it seems like what they're doing is maybe somewhat complex, is really using packages, primarily the Tidyverse family of packages, and really primarily the dplyr package, which is really supported with many of the R versions, and therefore can be used on most government workstations. Justin and I sit at the Pentagon, and while we have developed these packages over at Technomics, we've done similar data manipulation tasks at our workstations there, with next to no issues in terms of versioning or requiring the latest version. So yeah, that's a great question, and certainly a valid concern, but I think that's okay.
Yeah, and just to address a little further, I know there are a few top secret sites that only allow base R to be used. But yeah, like Ben said, we sit at the we've talked to a few other people in their sections, and the packages that are leveraged within ours are some of the most basic ones that are allowed in other places. But yeah, we are still working on that rollout plan. Thanks for that question.
Excellent. All right, I'm going to try Jeff one more time. And if we can't get him this time, Jeff, are you ready? Oh, well, I've got 3 versions of them on here, so I will just ask it for him. Are these packages on Crayon, C-R-A-N?
Yeah, that's a good question. So Crayon is essentially the repository where anyone can go and download an R package from. These packages are not listed on Crayon. However, we're not planning for this to be a pay for software license. That's not the distribution model we're planning at the moment. So not on Crayon, but also not a pay for model. The distribution model will be somewhere in between. And for a little bit more information, we definitely do just encourage you to reach out to us for how to start using the work.
Okay. Matthew Kiefer, if you want to unmute yourself, you can ask your question.
Hey guys, great presentation. I'm curious, and this is a little bit more general question, why you decided to develop this in R as instead of Python?
Yeah, that's a good question. I'll let Justin weigh in, but for the most part, our company, we're Technomics, we're a company of analysts that use R quite heavily, and Python to a bit lower extent. So, again, as Justin mentioned, everything with R we learned on the job. We learned from our Technomics colleagues, essentially. So for that reason, that's kind of the language and the workflows that we kind of grew our skill set in. And with the government analysts that we work with, we work with some CAPE analysts. They're using R as well. So it allows us to collaborate with them too. Certainly you could, do a lot of the same data manipulation tasks in Python. R is also great for data manipulation. However, so that's what led us to use R.
Yeah, for those in the audience that aren't aware, Python and R are 2 of the more leading softwares that are open sourced for data analysis currently. And yeah, I think Ben wrapped it up pretty well. It was a choice definitely that could have gone either way, but we have noticed, a few of our colleagues within the government using R as well as some with Python, but some of our more senior data scientists at our company who we've worked with and learned from definitely have a vast experience in R that we've definitely
Hey Justin, Ben, can you hear me?
Went to the decision.
Yeah, we can hear you.
Okay, I'll give a little less political answer there, in which this work actually just makes a lot more sense in R, to be honest. By the way, this is Adam James.
There you go.
For those of you who don't know me. The reason why this makes sense in R is simply some characteristics on how the language is built. The extensibility of it and the ability to make and distribute custom packages is a little more streamlined in that front, everywhere from distribution methods to the packaging structure in itself. So the fact that, 1, it's a little more accessible from government networks. 2, we have a strong user base on it, a little more so than Python. But 3, the fact that we can weave this in with the documentation. I can chain it together easy to other packages for dependencies, and a few things with lazy evaluation and some other technical nuances with R kind of make it a little more conducive for something simple like this, because we don't need to leverage some of the things that Python actually has greater strength at, such as some of the more sophisticated ML libraries or what have you within that. So that is part of the reason why we selected our route as well.
Great, thank you everyone for the answers.
Cool. Well, I'm going to unmute one more person who's going to talk a little bit and then give you guys a little more time to ask some questions if you like. Mr. Collins, if you're ready to speak, you may unmute yourself.
Thank you so much, Megan, and good afternoon or morning or evening, depending on where you are, and everyone who joined us today. Really pleased you did. Yeah, Megan, at the close of the presentation, Ben and Justin's presentation, put up a slide advertising the next ICEA workshop in Minneapolis, and I wanted to footnote, yes, the encouragement to get abstracts in. It's never too early to do that, but I'd like to go one step further. And today's presentation is an example of this. If you're fortunate enough to have an abstract accepted, I strongly encourage you to go the extra mile and write a paper. And I'd say there's at least 3 good reasons for doing so. First one is it qualifies you for a best paper award, and the recognition that comes with winning a coveted ICEA Best Paper Award. Now, Ben and Justin were not did not get a Best Paper Award for this one, and in fact, many of you probably participated in some or all of the earlier webinars that featured the Best Paper Award winners, but you can't win a Best Paper Award unless you write one. So that's reason number 1. Reason number 2 is the process of authoring a paper is truly an invaluable learning experience. I'm sure Justin and Ben, would attest to that. And it's a learning experience that could set you apart from your colleagues. My honest opinion is that effective technical writing is becoming a lost art, and an ICEA paper is a really good opportunity to practice. Certainly, having the ability to prepare effective briefings is an important skill, but being able to write full sentences is an equally, if not more important skill. So that's reason number 2, the practice writing and conveying thoughts. And then reason number 3 is that your paper will be forever readily available, not only to ICEA members, but also the general public by virtue of the ICEA workshop archives that includes 12 years worth of workshop papers and the associated presentations. So you've got a piece of work that's out there, and if someone Googles your name, it's going to take them to, at least one place it's going to take them is to the ICEA archives, and your work will be available. So anyway, thanks, Megan, for letting me add that.
Well, of course. And I think with that, we didn't get any more questions in the meantime. So I think Ben and Justin, you did a fantastic. If you want to slide it on back to your contact info so we can see that. There we go. If anybody has questions, go ahead and reach out to one of the guys, Adam, Ben, or Justin. And if for some reason you lose that or need to get in touch with them or any of our other speakers so far, you can always contact the ICEA office, and we will be happy to forward your message on to the relevant parties. I'll give Ben and Justin any final words before we part.
No, yeah, thank you, Megan. Thanks for allowing this opportunity to still present, even though we weren't able to in person. Really appreciate it. And yeah, the webinar software worked great. So thanks for setting this up, and thanks for tuning in, everyone. But that's all we have.
Well, thanks, guys. Thanks, everyone, for coming. I really hope I also am bummed out that you guys didn't get to present them live, and I'm looking forward to everybody's presentations next year. And I hope many of you will send in abstracts to the Call for Papers site. And until then, if you have questions again for ICEA, reach out to us. We'll listen to you guys next week at our next webinar Wednesday. And then until then, have a great day. I just blanked. You know what to do. Be good to each other and have a good time and all that jazz. And I'll quit while I'm ahead. Thanks, everybody. Have a good one.